All right, so I'm going to go through it. Obviously, if you need to make adjustments, you can do so on that class kick. But then when we get to the end, please make sure that you export it to Notability so you have it. Once I close out that class kick, you will lose access to it, okay? You don't need to do anything to submit it on your end, whatever you work out, I see. So just keep that in mind. This says put the equation into standard form. So what this means is do complete the square, okay? So I'm going to group the first two terms together. I get 2x squared plus 3x. Leave the space because I'm going to fill it in, bump the 5 to the outside. This is one of those cases where you've got something on the front, so you've got to take it out. We take out the 2. I get x squared plus 3 over 2x. Leave the space. Minus 5 goes on the outside. Now I've got to take that 3 over 2, divide it by 2 or multiply it by a half. I get 3/4, and then square it. And I get 9/16. That's what I'm going to add inside my parentheses. And normally it's what I subtract from outside the parentheses. But I have to take into consideration the 2 before I do that. So whatever's on the front, I multiply by what I got from my dividing by 2 and squaring it. 2 goes into 16 8 times. So now I'm subtracting 9/8. 5 becomes 48. And I end up with 2 on the front, square root the first term, so it's x, square root the last term, so it's 3/4. Take the sign from the middle term, so it's plus, put it in the parentheses, square it. 40 minus 49 is negative, 40 minus 9 is negative 49 over 8. Here is my standard form.
Where did 1/2 come from? To get to 9/16.
You got to divide by 2, and dividing by 2 with a fraction, same thing as multiplying by a half.
Oh.
So you always take that second term and you divide it by 2, then square it to figure out what the last term's going to be. Questions on this, because it's a little rocky on your work, so make sure that you understand that process. I warned you yesterday, they're not all going to be pretty numbers, okay? I am looking to do like a 2-part quiz on this stuff. One in which you do a video going over complete the square, and then the rest answering questions from the next couple, from like 1-6 to 1 to 2. Okay, once I get all the logistics of that worked out, I'll let you know. But just think that that's probably going to be part of your grade instead of just, like doing it on a test or a quiz. You're going to actually do a video like I just did, explaining the process. So you'll get a question, you'll have to explain it in a video, and then submit to me a video. Okay, so now I'm going to carry that over to the next one. So f of x equals 2x, if I can remember it, plus 3/4 squared minus 49/8. Okay, here's my now equation, right? So hopefully the vertex is quick. That's your HK, opposite of what follows x, which is negative 3/4. And then whatever it is after the parentheses, negative 49/8. When I graph that, that means that's negative 3/4, and that means that's negative 6 1/8. Obviously, I need to convert that to a mixed number in order to graph it. How you answer that, however, is either way. My intercepts, so if I want to find the y-intercepts, I'm going to plug 0 in for x. Now, here's the trick. You can either plug it into this form, or you can plug it into the original form, which was 2x squared plus 3x minus 5. F of x equals that, okay? And this time, because of those fractions, it might be easier to plug it into my original. So if I do that, I get y equals 2 0 squared plus 3 times 0 minus 5, gone, and y is negative 5. Much easier to plug it into the original. Sometimes there's not that much of a difference, but because our answers from our complete the square and our standard form have so many fractions, it's probably easier to do that from the beginning. So here's my y-intercept. Then my x-intercept. Also probably easier if you're good at factoring from the beginning. If not, this gets ugly. It can be done, so maybe I'll show that to you in a second. But if I have 0 equals 2x squared plus 3x minus 5, I can find the factors of 2 times negative 5, which is negative 10. That sum to my middle term. So negative 2 and positive 5. Replace my middle term with those two terms. Oops. And then factor by grouping, take out a 2x, x minus 1, take out a 5, x minus 1, and I get x minus 1, 2x plus 5, which is also what you can get from trial and error. Solve these, and I get x is 1, and 2x equals negative 5, and x equals negative 5 halves. There's my x-intercepts. Okay, oh, I didn't put on here axis symmetry, do that as well. So I'm gonna go over max and min because we didn't do that yesterday, but also add axis of symmetry, x equals negative 3/4. Something obviously you need to know. Okay, if I had solved it using this format, I would have gotten 0 equals 2 parentheses x plus 3/4 squared minus 49/8, right? Add the 49/8. Divide by 2 or multiply it by a half. Square root both sides, putting a plus and minus on the left. Square root of 49/16 is 7/4. Subtract the 3/4, and there's two equations here. X equals negative 7/4 minus 3/4, and x equals positive 7/4 minus 3/4. So I get negative 10/4, which is negative 5 halves, and 4/4, which is 1. Same answers I got from factoring. Now I'm going to use all that information to graph my function. So I've got my vertex negative 3/4 and negative 6 1/8 about here. X intercepts at 1 and negative 5/2, which is negative 2.5 here. Y intercept at negative 5. Now we're going to talk about it today, but remember a minimum is the lowest point, right? The difference between what we did before with relative minimum and absolute minimum is that these are absolute. There's only one. And in this case, we give just the k value. So there is a minimum because it opens upwards. So it's a minimum, and the value is negative 49/8. So when you do absolute max and min, you just give the y coordinate of your vertex or the k. You do not give it in coordinate point form. That's the difference between relative min and absolute min. So again, part of your quiz grade for this section will be what we just did. Questions on this? So please, now that you've corrected it, made your adjustments, whatever it is, export that to Notability so you save it. You could call it warm-up part 1 because that's what it is, 2.1 warm-up part 1. We'll finish the rest tomorrow. All right, so we're going to finish 2.1 today, which was quadratic functions. You can ignore that page number. That's
the graph.
So yesterday we left off here, graphing without standard form. I told you yesterday that when it's not in standard form, you have two options. One is force it into standard form, which is what complete the square does. The second is to work through it this way. So this again is quadratic, and I know it's quadratic because it has an x squared and it has an x. That's how I know it's quadratic, not standard form. When it is like that, okay, your other option is to find the vertex by doing negative b over 2a, and that's your h. Then plug that back in to get the k. So you plug it back in, you solve for y, and that's your k value. So that's a fast way to get your vertex without having to put it back in standard form. From there, your axis of symmetry is x equals h, which you'll know. Then you can find your intercepts. Usually from this, we factor. If it's not factorable, we can use the quadratic formula, which is negative b plus and minus the square root of b squared minus 4ac all over 2a. If you really want to get a song stuck in your head, you can go to the YouTube videos, and there's one that does Pop Goes the Weasel of that. I won't sing it to you. You're welcome. And then just like we did before, you can graph these using your vertex and your intercepts, and then again, any additional points that you might need. All right, so here we've got find the vertex of the function f of x equals negative x squared minus 3x plus 7. So the a is what's in front. Instead of going through the process of complete the square, I'm going to do it the short way. The a is what's in front of the x squared, which is negative 1. The b is what's in front of the x, which is negative 3. C is 7, but I don't even need it right now. The h, or the x coordinate of your vertex, is negative b over 2a. So negative 3. Over 2 times negative 1 would be 3 over negative 2. That's the h. Then I have to plug that back in to find the k. So I'm going to take and plug it back into both x's. This is a negative on the front. The negative 3/2 gets plugged in parentheses. Square it, minus 3 times negative 3 over 2 plus 7. Square, then take the negative from the front. So the square of negative 3/2 is opposite of 9/4. Negative 3 times negative 3/2 is positive 9/2 plus 7. So this becomes negative 9/4. I need them all to have a denominator that is 4. So this is 18/4, and this is 28/4. Negative 9 and positive 18 is 9. 9 plus 28 is 37 over 4. And that's the k. So this is a y equals, but it's a specific y. It's the y that is the y coordinate of my vertex, which would also be k. So many things I know from this short amount of information. One, I obviously just from my vertex, but because it's negative, I know this parentheses opens down. I mean, I know this parabola opens down. And then the max this time, because we're about to get to that, would be the k, or the y coordinate of my vertex. So speaking, if my A is positive, then I know this opens upward, and if it opens upward, then I have a minimum. If my A is negative, then it opens downward, and if it opens downward, I have a maximum. Only the K. So again, not coordinate points. Different from before because this is an absolute max and min. Be careful because you have access to your calculator and you have access to a graphing calculator. Don't use those to find your max and mins because they're going to be fractions, and what you're going to give me is decimal, and that's not what I want. Okay? So a lot of times these are fractions. You got to be really careful. Negative b over 2a, take it, plug it back in, get the k. That k is your max or your min. All right, so this says, for the function f of x equals negative 3x squared plus 2x minus 5, without graphing, determine if it has a max or min, and then find it. So just from looking at this equation...
I'm sorry, can you go back to that page again?
Sure. All right, so without having to graph this, right, you should be able to look at this equation and tell me which direction does it face. It's down, good. And if it's down, it has a what, max or min?
Max.
It has a max, so I already know that part. Now I got to find it, okay? So negative b over 2a A is negative 2, B is 2. Negative 2 over 2 times negative 3 gives me negative 2 over negative 6, or 1/3. That is the H coordinate of my vertex. I need to take that and plug it back in to get the K. So I'm going to square 1/3 and I get 1/9. 2 times 1/3 is 2/3. 3 goes into 9 3 times, so this is negative 1/3 plus 2/3. 5 over 1 becomes 15/3. Negative 1 plus 2 is 1. Minus 15 is negative 14/3. And that's the K of my vertex, which is the maximum value. Again, you can use it like just as it is, improper, as long as it's simplified. Or you can convert that into a mixed number. Do not convert that into a decimal. So this is the same thing as negative 4 and 2/3, okay? But do not convert that into a decimal. Yep, go ahead, Maria.
What is negative 3x squared plus 2x minus 5 in your work problem? But in our notability, it says plus 5.
Okay, I don't know why that is. Go ahead, change it to minus 5. I really don't know. Oh, I know why. Because I used to use this example to show how you could also find your points, and that's not factorable. Questions on that one? Yeah, I think because I didn't. No, I do. Okay, I'm going to keep going. All right, so it says identify the vertex, the x-intercepts, and then use the graphing utility to verify. So if I am going to find the vertex, I'm going to do it the way we just did. Okay, I obviously could complete the square, but I'm going to do it the way we just did, which is negative b over 2a. So if a is negative 3 and b is 2, then this is negative 2 over 2 times negative 3, which is negative 2 over negative 6, or 1/3. So that's the x coordinate of my vertex. Now I'm going to plug that in to both x's to get the y coordinate of my vertex. Negative 3, 1/3 squared plus 2 times 1/3 plus 5. Negative 3 times 1/9 plus 2/3 plus 5. This is negative 1/3 plus 2/3. 5 over 1 becomes 15/3. Negative 1 plus 2 is 1. 1 plus 15 is 16/3. That's the y coordinate of my vertex. Because this opens downward, that would also be a max if it had x'd. Now the x-intercepts come from setting this equal to 0. 0 equals negative 3x squared plus 2x plus 5. I'm going to factor this, multiply first times last, negative 15. Factors of negative 15 that sum to positive 2, positive 5, negative 3. Substitute those back in the place of the 2x. And factor by grouping. From the first one, I can take out an x. Second one is already the way I want it to be, so I take out a positive 1, okay? That's what we would do to not change it. Then I get negative 3x plus 5 and x plus 1. Now, my coordinate points are 5/3 and negative 1. And then it doesn't say to do it, but let's do the y-intercept because that one's easy. From quadratic form, if I just plug in a 0 and a 0, they're gone. And my y-intercept is 0, 5. So y-intercept is super easy, probably the easiest thing to get from quadratic form, not standard form, okay? It's not as easy from standard form. So now I've got my vertex and my intercepts. I'm going to pull in a graph. Not that way. One third and 16 over 3 is 5 1/3. So 1/3, 5 1/3 is about here. Y-intercept 0, 5. X-intercept -1 and 5/3, which is 1 2/3. And then just connect your points. So again, quiz-wise, you're going to get asked to complete the square to get standard form for one question, right? Probably same for tests. That is going to be a process to get it in to complete the square. But then once you have it there, you have options of how you want to graph it. Do you want to use negative b over 2a, or do you want to pull it from the equation? If it's in standard form, HK is way easier to pull it from the equation. If it's not in standard form, negative b over 2a is faster. And then when you go to get your x-intercepts, your y-intercepts, you also have choices. If your equation is in quadratic form, meaning you have the x squared and the x, it's probably easier to factor it if it's factorable. If not, you go from standard form. That's fine. You just got to remember your even root property like we did yesterday. Subtract the 5, square root it, plus and minus, all that stuff, okay? Doesn't mean it can't be done. For me, I bounce back and forth between the two formats, so that's you want to get comfortable with doing both. Y-intercept's definitely easier from quadratic form because you just plug in zeros and then it's the last number. Anybody still copying that down? All right, now you've got your graphing calculator component, right? So let's say that the function asked you to find the k value using your graphing utility, or your max and min using your graphing utility, because it will. I think there's homework ones that ask this too, okay? This is, I mean, I taught you this last week, but okay, so we did this last week and the week before, but we're gonna do this, okay? If I were to take that function that I just had, which is y equals, it was 3x, right? Positive 3x. Yep. 3x squared plus 2x, and then mine was minus 5. And I graph this. Oh, my window's so zoomed out.
It's negative 3x.
Is it? Thank you. Remember that the negative has to use this. It's got to be the one over the A and S button when it's a leading negative. Otherwise, it's going to give you an error. All right, so this is what it should have looked like, okay? Now, if I want to know what that maximum point is, remember I go second trace. I'm going to go to a max because that's what this is. I go left of my max, so right there's fine. I go right of my max, which anywhere on the right's fine, and then let it guess, and it's going to bring me directly to my point, which is 0.3 repeated, comma, 4.6 repeated negative, which matches what we just found, right? That 1/3, and then plug that back in. 4.6 repeated would be the same thing as 4 2/3. So if this was the case where it said to use your graphing utility to find it, of course we would round that. That would be negative 4.7, and it would be a max value. Remember that you can also use your graphing utility on your iPad. For now, when we're back in the building, it will be different. But for now, you can use the graphing utility on your iPad. Also keep in mind that on a standardized test, you would not have your iPads. So you definitely want to get to know your handheld graphing calculator, because it's a great tool when you're going to take a standardized test. All right, questions so far? Okay, next comes the graphing calculator. All right, so now what happens if I want to find the equation of the quadratic function. I'm working backwards here. So I'm going to plug in the vertex that they give me, which is going to be an HK. I'm going to plug in the point that they give me, which is the x and y, into my standard form, y equals ax minus h squared. Actually, there won't be an a. No, there is. Plus k. I'm going to plug it back into this. The variable I won't know is a. I'll solve for a, and then I'll plug back in just the vertex, which is your hk, and your a. And your end result will be a y equals, there will be a number here, x minus, there will be a number here, squared, plus, and there will be a number there. So we're working backwards. Just like with the circles, I'll give you pieces of information. This one's super easy. You just have to plug those in, solve for a, and then plug back in the a, the h, and the k. Okay, so that kind of question would look like this. Find the equation of the parabola in standard form. The vertex, 512.715. So the vertex, and it's important you give them the right letters, right? The vertex is my h and my k, and the point is my x and the y. If you switch those, you get a different answer, so be really careful. So then it's y equals ax minus h squared plus k. The y is 15. The a is what I don't know. The x is 7, the h is 5, so 7 minus 5, squared, plus the k is 12. Then I'd get 15 equals a times 2 squared plus 12. Be careful here, because what happens is, well, this is what, I don't know, like, you guys are so smart, and yet people do crazy stuff sometimes, like 4 plus 12. Then they take and add 4 plus 12. That's not right. Don't do that, okay? So I'm going to subtract the 12, and I get 3 equals a times 4, and then I'm going to divide by 4, and I'm going to get a equals 3/4. A will already have its sign on it. If it's negative, it will show up in that equation. If it's positive, it's like it is right now. That's right, okay? So you don't have to worry about figuring out up and down, which way it faces. A is already going to work out its own equation, or its own sign. Okay, so now I'm going to go to my equation and plug back in the h and the k and the a. Y equals a is a positive 3/4, x minus 5 squared plus 12. Now, if I had the time, let's face it, the way you guys work, you probably won't. But if I had the time, I could check this. I could plot both these and the equation and see if I'm at least on the right track, okay? It would only be 2 points, but at least it would be, I'd know like if I'm way off. Questions so far? All right. Oh, yours says, right? Fine, Max. That's why I didn't answer it. Min. This is a parabola that opens upward because it's got a positive at the front, right? Which means it has a minimum. And the minimum value is the k or the y coordinate of your vertex. All right, so now we've got some application of those quadratics by way of word problems. This says you have 64 yards of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximizes the enclosed area, and what's the max area. So on the little drawing there, it's telling you that the length is x, the width is 32 minus x, and I want to maximize the area. So I need a couple of things here. One is, what's the formula for the area of a rectangle?
Ours squared?
Yours.
Yeah, by a lot.
What?
Complete question.
Ours is very different.
Okay, so back to this one. So I need the area, right, of a rectangle. And I need to set up my, obviously, we're going to set up a quadratic here. So the area of the rectangle is length times width. Okay, I have the length and the width here. But it's saying what's the maximum amount of area. So I want to know if I have 64 yards of fencing, I want it to be less than or equal to that, right? Because I can't go over it. So maximum area means it's got to be that or less than that. And it would be x times x minus 32. So I'd get 64 greater than or equal to x squared minus 32x. Then I would move the 64 to the other side, okay? And I'd get 0 is greater than or equal to x squared minus 32x minus 64. So if I want to know the maximum value here, okay, then I want to figure out what the max is of this function. Oh, I think I know why. I wrote that wrong. Hang on, guys. I wrote this is switched. 32 minus x, which makes a lot more sense because otherwise you've got a positive. Okay, so here I am, right? So now I know that this would be a parabola that opens downward. The maximum value, and I'm going to find it using my graphing utility, is negative x squared plus 32x minus 64. I can also find it by doing negative b over 2a and then plugging it back in to get the y, but this is obviously faster. Now that negative 64 is way down, right, because it's all the way in the bottom. So I'm going to have to zoom out a lot. Actually, you know what? I'm going to do this on the
Yeah, because I saw it was like near like 200. So
Yeah. No, it's easier to do this one on the graphing utility because you can pinch and zoom easier.
Right. Yeah, I did it on just on my actual calculator.
Okay, so you'd have to zoom out a lot, but like think about like that. You would know hopefully that would be your y-intercept at negative 64, which means you're gonna have to zoom out. And because it's so big, I would probably have used the zoom feature till I could at least catch it all, and then try to figure out where that coordinate point is. All right, so the max amount of area would be 192. That's just kidding. That's the max value. What it wants is the max area. So if I had asked for the max value, right, I would have, that's 192. But the max area, I actually have to take the 16, plug it back in, and that's when I get that 192. So 192 can be found either way, from the max if you plug the 16 back in, or the actual y coordinate, which is what you would have got there, and it did give me yards, so it'd be 192 yards.
I'm still a little confused because my graph doesn't even cross the it's nowhere like positive. What'd you plug in to get that?
So it should be negative. Here, I'll show you what my y looks like. That's what I typed in, just like that. That's a negative, that's.
Yeah, I did the same thing, and mine is super. I can't really see it. Mine's super far down.
So you have to. What do you mean super far down? Like if I zoom out, I get this. I had to zoom out twice though. I'd have to zoom out even one more time to get all of it.
Oh, because you didn't. Because I changed the window.
You'd have to change the window a lot because that top is 192. So your Y max would have to go bigger than 192. Does that make sense? Once you get a better idea of where it's at, then I would probably change the window. But I have to figure out where that is first.
Okay.
Okay, last one, and this is the one that's in yours, right? So it says the height in feet of a punted football is approximated by that big long function, where x is the horizontal distance in feet from where the football is punted. Use a graphing utility to graph the path of the football. How high is the football when it's punted? What's the maximum height of the football, and how far from the punter does the football strike the ground? So the first thing I have to do is type in that big long, let me see if I can do both, that big long equation either into my graphing handheld calculator or into the app. You have to put the the fractions in parentheses. So the negative can go on the front. Open the parentheses, 16 divided by 2025. Close the parentheses. X squared plus 9/5 has to be in parentheses. X plus, open the parentheses, 3 divided by 2. Close the parentheses. Save it. So it looks like that, and that's how it would have to look in your handheld graphing calculator too. It would have to be in parentheses. Now I'm going to graph it. All right, so think about what it's asking for here, right? It says a couple of things. It says one, well, A was just graph it, which we did. B is how high is the football when it's punted. So that means when it's at 0, right? If you've ever watched football, they don't punt from the ground. And if you haven't watched football, you just learned something about it. A punt does not sit on the ground. A punt, a kicker physically drops it and then kicks it, which means it's going to be off the ground, okay? And that's the first question here. That would be represented by the y-intercept. So if I double tap this screen and I go to trace the graph and I get that y-intercept there, it's 0. Actually, let me get even closer. It's like 1.5. Is it feet? Yeah, it's feet. Okay, that's your y-intercept. That's where it would be when he punts it. C says, what's the maximum height of the football? So now I need the maximum height, and I'm talking height, which would be the y coordinate of my max. Stop doing that. Which is all the way up there, okay? And again, it's the y coordinate here, which is 104.0 feet, or 104 feet. D says, how far from the punter does the football strike the ground? So that's happening again all the way over here at the second coordinate point when it hits the x-axis, the second root or the second x-intercept, which is 228.6 feet. So this is 229 feet. There are going to be word problem applications. You're going to try to have to figure out what they're going to ask you. It's either going to be something related to a max and min, something to where it hits the ground, stuff like that. So keep that in mind. If it had asked for the horizontal difference, like where on the ground does it hit the highest point, that would be the x coordinate of your vertex. Vertex or your max and min. So think about stuff like that. So again, you will see questions that involve word problems that you're going to have a graphing utility for. For now, you can either use the app or you can use your phone, but just keep that in mind. I mean, you can use your app or you can use your handheld, but keep in mind that should this have been standardized or should this be in the physical building, that you would need to know how to use your handheld graph as well.
Ms. Christweiser?
Yes.
We can repeat number, everything.
Yes, sorry. So how far does it hit the ground? That graph went like this, right? And if this is my punter, how far does it hit the ground? This is my ground, right? So it's going to come back and hit the ground at that coordinate point, which was 228 point something, and then whatever the y is 0, right? Because it hits the ground. So I want to know how far from the punter he is. The punter's here. This horizontal distance would have been it was like 228.8 or something like that, to approximately 229 feet. You have this, oh no.